Our example problem is y equals the square root of 4 minus x squared from -1 to 1 rotated about the x-axis. If we were to square both sides, we would see that this is just a circle with radius 2. So we've got circle with radius 2, like so, rotated about the x-axis, noting we want to go from -1 to 1. So we just want this section right here. That is our shape. It's kind of hard to see, but since we're rotating around the x-axis, our radius is going to be f of x. And our surface area function, the integral of 2 pi r ds. Let's try to do this in terms of x. So we're going to integrate from -1 to 1. We could factor out the 2 pi. Our radius is just the height function, so that would be the y function, square root of 4 minus x squared. Since we're doing this in terms of x, times the square root of 1 plus f prime of x squared dx. So f prime of x is going to be 1 over 2 square root 4 minus x squared times a negative 2x from the inside derivative. So we have 2 pi from -1 to 1, square root of 4 minus x squared, the square root of 1 plus all that stuff squared dx. And we note 2 over 2 can cancel out. Also, we see that we're going to have an x squared in the parentheses, and we have a perfect square down on the bottom under the square root squared. So what are we left with? -1 to 1 of the square root of 4 minus x squared times the square root of 1 plus x squared over 4 minus x squared dx. At this point, we can get a common denominator for that square root. And it looks like we'll be able to combine some like terms here and here, which leaves us with a perfect square in the numerator of +4. And also note, it looks like we're going to have a bunch of stuff cancel out. So we have 2 pi from -1 to 1 of 2 dx If you want, you could use symmetry and double this integral so that we have, bringing the 2 out, we have 4 pi times a 2 from 0 to 1 dx. And integrating that, we just get 8 pi x from 0 to 1, which is just 8 pi. And that's the end of the problem.